Done, sir.
Now listen, we are fitting a binomial distribution for this following data. So can you figure out what is the n value now? N value. It is running from 0, 1, 2, 3, so on up to 5. That n will be 5. Directly this number n will be 5. Just I'll give you a hint. You have x plus y whole power n, then nc0 will come.
Yes, sir.
That 0 is this 0. nc1, nc2, so on up to nc5. That is 5c5. So these numbers are having these many values, but where is the end? That 5 will be n value. Okay? That 5 is n value. What is given here? Frequency? Frequency is given as 2, 14, 20, 34, like this.
Yes, sir.
Now we find the binomial frequencies as follows and hence obtain binomial distribution. See the table, it's very interesting. First of all, what is recorded? That given x values are recorded and given f values are recorded. Last column is for totals. Okay? Now fx will be f into x. It is 0 here, 1, 14 is a 14, so on like this. That I need not to spend time on this one, right?
Yes, sir.
Now next comes binomial
Distribution.
probabilities. Binomial probabilities. That is 0.015. Can you tell what is this one? Actually, here is the table. Below the table I have calculated values. I'll show you that one.
Yes, sir.
Mean is how much? Sigma fx by
F.
sigma f.
Sigma F.
Sigma f, all complete frequency. The total was 100 here and sigma fx total is 284.
284.
Shall I go to previous page and show you again the totals? No need.
No need.
No need. So it is 2.84.
84.
So NP, what is this NP?
Mean.
Mean is NP. Now this mean NP is 2.84. What is that n value I said you?
5.
So you are writing 5p is equal to this, p is this by 5. Since n is equal to 5, p value we got it, q value we got it.
Yes, sir.
Now I am calculating the binomial
distribution.
probabilities. Binomial probabilities. For x equal to 0, what is the probability? 5c 0. This p value power 0,
Yes,
q value power 5. That is 0.015. Now here I have written 5c 1, this 1 and this 4. What is this 1 and 4? That powers, if you add it, you have to get it this 5.
5. Yes,
So we got all these values. Shall I move forward?
sir. Yes, sir.
You are ready with the probabilities, right?
Yes, sir.
Now we will come to the table again. I'll just give a simple example. If a coin is tossed, what is the probability?
1 by 2.
1 by 2. That it will show head. What is the probability that it will be showing tail? 1 by 2. Suppose we are talking about head, that is 1 by 2. Probabilities are ready with us, right? Now, if a coin is tossed 150 times,
50 times.
50 times, tell me how many, what is the probability of getting head? 1 by 2. If it is conducted 100 times, then 150 times, then half of that will show heads, no?
Yes, sir.
75 times we are expecting head, 75 times we are expecting tails. So how that 75 will come? I have to multiply the total number of trials, total number of tosses, that is 150. I should multiply to 1 by 2. Then that 1 by 2 into 150 will become 75.
Yes, sir.
So total n value you have to multiply with the probability value to get to that figure, right? I hope you have understood. So what is this value? 100 into p. Why I am multiplying 100 into p? Total number is total frequency is 100.
Yes, sir.
So that is nothing but the n value.
N value.
That n value 100 I am multiplying with the p. Then are you getting that? I will show this. You are adding all these frequencies. This frequency 2 plus 14 plus 20, all this. Then you will get 100.
Yes, sir.
So this is part-wise frequencies. Total frequency is how much? Means it is like that. Okay, got it. No need of explaining. So total is 100. So we have to multiply that 100 into probability.
Probability.
So this is p value, this is p value,
Yes.
and this is 100 into p. So simply speaking, 0.015 probability into 100 will become the 2 places it will jump. So it will become 1.5. Similarly, it becomes,
9.5.
I will not tell now, you understood all these things.
Yes, sir.
Now, this is the frequency given by binomial distribution. So this should be rounded off in some way and write binomial distribution now. So as per binomial distribution, the 1.5 I am making it as 2, 9.5 I am making it as
10.
10, 26 here, 34 here, because it is 0.1 I have dropped. So this binomial frequencies, if you add, it should match with 100 or not.
Yes, sir.
So that these values are nothing but for the binomial distribution. Now just to come back to that same question here. Do you remember this now for 2, 10, it's how much? 10.
Yes,
This
sir.
is not a dot, okay? This is 10. 2, 10, 26. Just keep in mind these three numbers. 2, 10 and
26.
26. Come to this. It was 2,
Yes, sir.
it is 14,
26.
26.
20.
No, 20
20.
here.
Yes,
So these three numbers are actual frequencies. We are trying to fit a binomial distribution. Then binomial distribution is telling some numbers, no?
Yes, sir.
What was that numbers? Do you remember?
2, 10, 26.
2, 10 and
26.
So 2 is matching.
Yes, sir.
26 is close to this 20.
Yes, sir.
10 is close to this 14. Similarly, means this is the norm, this is the distribution, just the frequency distribution. But we are fitting binomial, then these numbers will come. So we have fit a binomial distribution to the given distribution. To the given frequency distribution, we have fit a
Binomial distribution.
understood? Are you able to understand that point?
Yes, sir.
Very good. Over. Now we are moving towards
Random variable.
Poisson distribution.
Poisson distributions.
So nice, you see. A random variable satisfies Poisson distribution with mean how much?
2.
2. Keep in mind, in binomial, we are having P and N, two parameters. Q is not special, Q is 1 minus P. So how many numbers are getting played there?
2.
Two numbers. That are parameters of the distribution, N and
P.
P. But here we will have only
Only one.
and only one parameter, that is mean.
Lambda.
That is lambda. So what we are finding now? Probability that x equal to 3, probability that x less than or equal to 2, similarly like this, 4 things. Now given mean of x is how much?
2.
Lambda, that lambda is equal to 2. So what is the formula for finding the probabilities? P of x equal to k. K I used for Poisson, R I used for
Binomial
binomial.
distribution.
That there is no fixed rule that you have to use k here or here. X also you can use both these situations.
Yes, sir.
So back to the point. This is the formula. E to the power of minus lambda. You just remember like this. E power minus lambda. That lambda immediately you write it here. Give the power and take the factorial of that power.
Yes, sir.
So will you be able to remember now?
Yes, sir.
Start with E power minus. E power minus. Write lambda. Then lambda power k. Then k factorial. Once you write lambda, lambda will come here. Once you write k, k will come here. Like that.
Yes, sir.
Somehow you remember. What are the values of k?
0,
0, 1, 2, 3, so on. Up to infinity also it is allowed. So for this, I have replaced with lambda value 2. That 2 has come here.
Yes, sir.
So what is the difference between that step and this step? We have substituted
Mean.
mean. That is lambda. That is like this. So what is the probability of x equal to 3?
K value 3.
K value is 3.
Yes, sir.
So it becomes e power minus 2. 2 power 3 by 3 factorial. 2 is written here, immediately 2 will come, power is 3, that 3 factorial will come. On simplification it is like this, leave it. I am not simplifying, right? Next. P of x less than or equal to, greater or equal to, sorry, P of x less than or equal to 2.
2.
Means P of x equal to 0,
1.
P of x equal to 1, P of
X is equal to
x equal to 2. Is this understood here that this 0 will come as the power? However, e power minus 2 and 2 are fixed everywhere.
Yes, sir.
Only power changes. 0 by 0 factorial, 1 by 1 factorial, 2 by
2
2
factorial.
factorial. On simplification, it's like this. I am leaving it to you. Assuming that you will not have You don't have any doubt in this, right?
Yes, sir.
Very good. P of x greater than or equal to 3. That is 3. 3, 4, 5, 6. How long you will write it?
Yes, sir.
You are stopping that. What is the sum of all the probabilities? 1. Sum of all the probabilities is 1. Means P of x equal to 0, P of x equal to 1, x equal to 2, x equal to 3, so on. That is equal to 1. But you want P of x greater than or equal to 3. You want from 3 onwards. So how many terms are there here? P of x equal to 0, P of x equal to 1, P of x equal to 2. So this taken that side, that will become 1 minus. So from 1, you just remove first 4 parts, okay? 3 parts. Because
Yes, sir. 0, 1.
we want 3. So we have to remove up to 2.
Yes.
So 1 minus P of x equal to 0, x equal to 1, x equal to 2. So 1 minus, this is already calculated in previous steps.
Yes,
That is why I have
by
replaced. Otherwise, you have to calculate this one. So 1 minus this one, that is finally this. Now we want from 3 to 5. Then you have to add up only this 3, this 4 and this 5. Understood clearly?
Yes, sir.
So here you see power is 3, power is 4, power is 5. 3 factorial, 4 factorial, 5
5
factorial.
factorial.
On simplification, you will get it.
Yes, sir.
Don't do simplifications and waste the time. Right? A random variable x satisfies
Poisson distribution.
Poisson distribution such that probability for 1 is same as probability for 2. Find mean of x and
P of 4.
P of 4. Don't get confused with P mean as equal to n into P. We are in
Poisson
Poisson
distribution.
distribution, right? We are in Poisson distribution. What is given? P of 1 is same as
P of 2.
written now P of x equal to 1, P of x equal to 2. This is short notation, but we have converted to actual meaning. Actual meaning is this one.
Yes, sir.
So we are substituting 1 here and substituting 2 here. What gets cancelled? E power minus lambda on both the sides gets cancelled. Lambda is lambda square by 2. Right? So this 2 comes this side. 2 lambda is equal to lambda square. Lambda square minus 2 lambda 0. Lambda into lambda minus 2 equal to 0. Mean cannot be 0. Means this lambda is one possibility. Another possibility is lambda minus 2. So lambda equal to 0 or lambda equal to 2. But we are not taking. Cannot be 0. Lambda cannot be 0. If lambda is 0, what happens, you know? What is the formula? Here, no? This one.
0.
Right? Lambda is 0.
0.
This will disappear. So there is no distribution to talk about.
Yes, sir.
Means it will give 0 for every number. P of x equal to 0, that is 0. P of x equal to 1, that is 0. Then what is that distribution giving us? Nothing. It is saying 0 probability for all. But the total probability should be 1, no?
Yes, sir.
So if you add all zeros, will it become 1?
No.
No chance. Therefore lambda cannot be
0.
0. So lambda should be how much? 2. When lambda is 2, we want P of x equal to 4.
4.
So what to do now? Lambda is 2. Here you see lambda is 2. I need for 4. So power is 4 divided by 4 factorial. I have not simplified this because
Yes,
there is
sir.
no need. Manikanta, don't turn. Now, fit a? No, nobody knows there who is Manikanta, right? Leave about it. I am not showing your face here. Huh? Fit a Poisson distribution. Here are these frequencies given. 123, 59, 14, 3, 1. These are the frequencies. Simple symbol, that is F, not necessarily F, it can be anything. So these are the values 0, 1, 2, 3, 4.
Yes, sir.
We have to fit some Poisson distribution which is satisfying these values nearly. So what to do now? Same idea. First of all you write x, you write x, you write f. So what is the total number here? Sigma f, that is 200. Fx is how much? The total is 100. So what is the mean? Sigma fx by
Sigma f.
sigma f. Mean of x is sigma fx by sigma f. Okay?
0.5.
That is 100 by 200, 1 by 2. This is lambda. So what is the lambda is 0.5.
0.5.
What is the formula for finding the probabilities? E power minus 0.5
0.5 power k.
Are you noting?
Yes, sir.
0.5 here, power k, k factor.
K factor, yeah.
Okay, good. Now we have to calculate what? What are the values that distribution is taking? What is that? It is taking 0, 1, 2, 3, 4. So we have to calculate the probabilities for this one.
Yes, sir.
X equal to 0. 1, 2, 3, 4. Very good. X equal to 0, X equal to 1, 2, 3, 4. Maximum value is 4. So we have calculated all the probabilities. The probabilities are like this.
Yes, sir.
Next, what we need to do, you tell me? Frequencies we have to calculate. So actually, you just remember one number from this one. What is that? P of x equal to 0, that's how much?
0.6.
0.6. That should come in Poisson probabilities now.
Yes.
Let us go back to the figure, table. Do you remember this 0.6?
Yes, sir.
This is P of
X is equal
x
to
equal to
0.
0. This is P of x equal to 1. So on up to P of x equal to 4.
4.
Now this is P values.
Yes, sir.
Now I am multiplying 200 with that
200.
P because the total count is 200.
200.
So adding all the frequency values, it is 200. But that 200 to be now distributed or separated in such a way that that satisfies Poisson distribution. So 0.6 into 200. This is P, this is 200 P. So what happens now? 0.6 into 120, that is binomial
Frequencies, sir.
frequencies. Okay, it is binomial probabilities. These are binomial.
Frequencies.
This is the error. I said I did not get time to erase that one. So what I have not done here? These are not binomial probabilities. These are
Poisson
Poisson probabilities. You make a small change in that in the PDF, right? Then
Poisson frequencies.
Poisson frequencies. This is
Poisson distribution.
nearly if you get these values in decimal,
Yes,
2.3 suppose, as we have
Nearby.
done earlier.
Yes,
2.3 is 2 like that. So 120 is 120. Here
60
we
is
have not
60.
got any
Point value.
point values. So I immediately recollected that it is not binomial. I thought of removing it. Once I recollected, I written Poisson distribution there.
Yeah.
Got my point?
Yes.
So what is the thing? It is binomial probabilities to be replaced with Poisson probabilities, Poisson frequencies. That Poisson distribution. I hope you understood up to here.
Yes, sir.
Very good, very nice. Question number
16.
16. Define the following. Uniform distribution and
Normal distribution.
normal distribution. Standard, normal, random variable. Uniform distribution is nothing but a random variable x is satisfying. Actually, the way of saying is that if x is a random variable x, when we will say that it is satisfying uniform distribution, if its if its probability function is given by, this one. I said earlier at that time in the class, it is only revision going on. I am not introducing new things now. I am just going for revision. So f of x, you remember 1 by b minus a. When x lies between a and b. When x crosses that b, after b it is 0. Before a it is 0. How to tell that one? 0 otherwise. Means if it does not satisfy this condition, we are going to take that as 0. Is this clear? That is the definition. What is the normal distribution then? A random variable x is said to satisfy normal distribution if its probability function is given by f of x equal to 1 by sigma into root 2 by e to the power of minus half into x minus mu by sigma whole square. But we will not be using that function, it's only for the definition I have written. Is it clear?
Yes, sir.
Now, what is standard normal random variable? Standard normal random variable. If x is a normal random variable with the mean mu and standard deviation sigma, then that z, this z is called standard normal random variable. What is the link between that? Z is equal to
X minus mu by
x minus mu by sigma. X minus mu by sigma. What is that next? Nothing. The 16th question having 3 definitions, that is over.
Yes, sir.
17th. What is this now?
Sir.
A random variable?
Sir.